Okay, hi everyone. So welcome again to E303. And for this video, I will discuss the analytic geometry sample problems. So for the outline, I hope we can get a brief overview using the sample problems of the following topics. So we will discuss the Cartesian coordinate system, lines, and then the conic sections. So the subsections here, we have the spherical, parabola, ellipse, and hyperbola. So for the first one, we have this two given points, okay, P1 and P2. Compute the midpoint, slope, and distance between 2 points. So if you have this given, as you're given, you want to find the midpoint. So to find the midpoint, what you want to do is to find the average of the coordinate systems. So for this one, we just want to find the average of x. So we have 1 and 5, and then divide by 2. And then 2 first. So 2 plus 6 and then over 2. Simplifying this, we do 6 over 2, so the midpoint should be 3. And we have 2 plus 6, which is 8, so we have 4. So the midpoint will be 3 and 4 between these 2 points. And then to find the slope, so how do we find the slope? So to find the slope, we have m is equal to the rise over run, right? So we have rise over run. Or in other words, we have delta y over delta x. So the slope is equal to the change in y. So we have the change in y, we have 6 minus 2, and then all over 5 minus 1. So the slope here will be 4 over 4. No? So 4 over 4, or that will be just 1. Okay, and then the distance between 2 points, so how do you find the distance? So the distance is just equal to the square root of the sum of the squares of their difference. So how is that? So we have to find the difference on this coordinate system. So we have 5 and 1. So 5 minus 1, and then square that. And then we have 6 and 2, and then square that as well. So the distance here is equal to, we have 4 squared, so 16, plus we have 2 squared, that is 4, right? So this will be equal to the square root of 20. We can simplify this further, no? So we know that this is just 4 times 5. And 4, or the square root of 4 is just, what do I call this? 4 squared. This should be 4, sorry. This should be 16, no? Sorry. 4 squared is 16 as well. Okay, sorry. So this is equal to 32, square root of 32. So 32 has a prime factor of, so we have 2, 16, so we have 2 again, and then 2 again, right? And then 2 again. So we have 8, 16, and then another 2. So what we can do here is this will be just 2 squared, 2 squared. So this will be just 2 times 2, and then the square root of 2. So therefore the answer should be 4 square root of 2, or that will be approximately, I have an answer here. We have 5.66. So this will be your final answer. Okay. So the next one, we want to find the equation of the line that passes through the points 0, 0, and 2 and negative 2. So what should we do here? So there are different forms of line or linear equations. So since we have two given points, we have to use the 2-point form. So the 2-point form, has an equation of, we have a y minus y1 is equal to, so we have y2 minus y1 over x2 minus x1. And then we have x minus x1. Okay. So actually, you can change this one, no? It can also be y2 here and x2 here. It depends, but you have to be consistent. If you use the first point, you have to use the first point for this 2. If you use the second point, you can use the second point for 3. So this should yield the same answer. So to make things easier, it is more practical to use this as your y1 and x1 to prevent additional computations, no? So substituting the values, we have y minus 0 and then equals 2. So y2 here is negative 2. So y1 is 0, so minus 0, and then x2 is 2, and then minus 0 again. And we have x, and then x1 is 0. So we have to simplify this. We have negative 2 over 2, so this will be negative 1, right? So negative x. Okay, so that will be it. So this will be your equation of the line. You can simplify this in its general equation. We have we have x plus y is equal to 0. So uh, this will be your answers. So a line goes through the point for a negative 6 and is perpendicular to the line y is equal to 4x plus 10. So what is the equation of the line? So how do we do this now? So if you have a given point and you have a given line that is perpendicular to this, so what information can we have here? Or what information does we have here that we can utilize? So for this, what information we have is that we have a point and we can find the slope of this. So we should use here the point slope form. Okay. Uh, so the point slope form we have y minus y1 is equal to m, and then x minus x1. Okay. So we have this given, although the m here is not yet given. So to find the slope, since this is perpendicular to this, so what can we know? What should we know about this? So if we have this line, we have y is equal to 4x plus 10. So based on the slope-intercept form, you can remember. So the slope-intercept form says that we have y is equal to mx plus b. Therefore, your m here should be 4, no? Right? Although it is said that this will be perpendicular. So to find the slope that is perpendicular to this, we should find, no, the inverse, the negative of its reciprocal. So perpendicular. So that the m here should be the negative of its reciprocal. So negative 1 over 4. Therefore, your new slope will be negative 1/4. So substituting the values here for your point slope form, okay, we have y minus y1. So we have, sorry, not negative 4, but plus 6, since this will be minus negative 6 and then equals to m. So m is negative 1/4. And then we have x and then minus 4. So simplifying this, we have y plus 6 is equal to, actually, the best way to do this is to distribute this 4, cross multiplying this to the other side of the equation. So we have 4y plus 24 is equal to, and then distribute this negative 1 to each. So we have negative x plus 4. Okay, simplifying this into its general equation form. So I will transfer everything to the left. So this will be I will put x first now. So x positive and then plus 4y plus 24 and then minus 4 is equal to 0. Therefore, simplifying this, we have x plus 4y minus, sorry, not minus, but plus 20 is equal to 0. So this will be your final answer. Okay, that's it. So what is the center and radius defined by this general equation? So we have x squared plus y squared minus 4x plus 8y is equal to 7. Okay, so what is the equation of a circle? So the equation of a circle, the general form, we have, sorry, that it is actually the standard form. So we have x minus h squared plus y minus k squared is equal to r squared, which is again standard equation of a circle. So what does this mean? So the h and k here is the center, okay? And the r here is the radius, okay? So to solve for its center and radius, what should we do? So we have to manipulate this equation, this general equation, into this form. So we have to use the completing the squares. So we have to group the x variables and the y variables together. So we have x squared minus 4x and then plus blank, okay? And then we have here plus y squared. So group this y is 8y and then plus blank and then equals to 7. So what shall we do here? We will complete the square so that this will become x minus h squared for this one, and then y minus k squared for this one. So to make this a complete square, we should add here 4, right? So if we had here 4 in the left side of the equation, we have to add 4 as well to the other side of the equation to make things balanced. And then we have 8y here, so this will be 16. 16, right? Okay. So plus 16 to the other side. So simplifying this, we have here x minus 2 squared, right? Plus we have y plus 4 squared and then equals 2. So we have 7 plus 4 plus 16. That will be 11 plus 16, so 27. Okay. So what can we see here? So we can already see here that the value of h and k, so the center of your circle will be 2 and negative 4. So why is that? So because the standard equation says that it should be negative h, no? So therefore h should be positive. So h is positive 2, and k here, since k here is in the form is y minus k. So if this is y plus 4, that basically means this y minus negative 4. So the k here should be negative 4. And then for the r squared, so we know that this is 27. So therefore the r here, or actually r squared is equal to 27. Therefore, we can say that r is equal to the square root of 27. So this should be your final answers for this problem. Okay? So for a given parabola, find the vertex and the length of the latus rectum. So vertex and the length of the latus rectum. So what is the general form of, or actually the standard equation of the parabola? So we have actually two different standard equations. So it depends if it is a horizontal or a vertical parabola. So if it is a vertical parabola, so we have x minus h. Yes, x minus h squared is equal to 4a minus 4ay minus k. So actually this should be positive or negative, no, depending on. So if it is positive, it is upwards, and negative if it is downward. And then for horizontal parabolas, we have y minus k squared is equal to 4a and then x minus h. So if it is on the right, pointing toward the right, it is positive, so plus and minus. If it is negative, this will be pointing or opening to the left. Okay, so since we have here a squared x and a non-squared y, therefore this should be a vertical parabola. So we should choose this one. So what should we do here? We can transpose everything that is not x to the right, and everything that has the variable x should be on the left. So we have x squared minus 4x, no? And then we want to make this a complete square, so we have to add a blank here for now, and then equals to, so this will be positive 16y and then positive 12. Okay, so to make this a complete square, we should add here 4. So we have to we have to add 4 as well to the other side. So if we simplify this, we have x minus 2 squared is equal to, so simplifying this will be 16y plus 16. So as we can see, we can also factor out the 16. So we have here 16 and then y plus 1, right? So what can you see here? So we can already know the vertex. So actually, I didn't point out now. So the h and k actually are, or the point of the vertex. Okay, so therefore we have h and k here as vertex. That is 2 and negative 1. So this will be your vertex. And then for the length of the latus rectum, so the length of the latus rectum is actually 4a, no? So the latus rectum, length of the latus rectum is equal to 4a. So as we can see here, based on this, okay, so the latus rectum is 16. So the length of the latus rectum is basically 16. Okay, that's it. Next one, so we have a given equation of an ellipse. So find the center and the eccentricity. Okay, how do we do this now? So we have 4x squared plus 9y squared minus 16x plus 18y is equal minus 11 is equal to 0. So find the center and the eccentricity. So to find the center and the eccentricity, we have to first remember what is the standard form of the ellipse. So the standard form of the ellipse, again, we have two different ellipses. We have the horizontal and the vertical. So for the vertical ellipse, or actually I will do the horizontal first. So for the horizontal ellipse, so we have x minus h squared over a squared plus y minus k squared over b squared. Okay. And then equals to r squared. So basically your ellipse will be like this, no? So horizontal. For vertical ellipse, we have still x minus h squared. But instead of a, we have b squared. And then for y minus k squared, we have instead a squared. And then equals to r squared. So this will be a vertical ellipse. So what is the difference between the two and what is A? So yeah, let's break this down. So the H and K here is your center. And then your R here is your radius. So what about the A and B? So the A here is the semi-major axis. And the B here is your semi-minor. Okay? So what does this mean? So if this is your ellipse, then the semi-major axis will be the largest. No, you can imagine this as your large radius. No, so this will be your A, and this will be your B. So for this one, your A here will be this, your B here will be this. Okay. So how do we now find the eccentricity? So for the eccentricity, let's break this down first. No, so eccentricity is equal to C over A. So what is C now? So we know what is A. So what about the C? So C here actually is the distance from a center to focus or foci, no? Center to focus or foci. No? And the C here is also equal to the square root of the A squared minus B squared. So you can think of this as a triangle, no? So you can think of this as a triangle wherein your A here is your hypotenuse, your C and B are your legs. Okay, so let's solve this now. To solve for this, we want to do again the completing the square. Okay, so let's group the x variables. We have 4x squared minus 16x. Okay, I will put a blank later. So additional here we have 9y squared plus 18y, and then 11. So I will transpose the 11 to the other side. So this will be equals to, so negative. This will become positive. So what I will do here is I can factor out this 4 here, right? I can factor out this 9 here. So factoring out this for each of this. So we have 4 times x squared. So factoring also the 4 here, we have minus 4x, right? And then in here, I will also put a blank. Ayan. And then for this one, we have 9 and then y squared plus, so factoring the 9 as well in the 18y. So this will become 2y. And then an additional blank here. And then equals to 11. So for this one, for the completing the square, to make this a complete square, you can add here 4. So what should we add to the other side? So if we add 4 here, should we add 4 here as well? So yes, we should add here 4 as well, but don't forget the multiplication of 4. So basically we are adding here 4 times 4 because we have to distribute the 4 here. So we have to subtract negative 16 to the other side, right? Okay. So, sorry, not subtract, but add. I forgot. If it is on a different side, you should add to make things balanced. Okay, sorry. And then for the other one, we have to add 1 here. So if we add 1 here, we have to multiply this as well by 9. So 9 times 1, so we have 9 to the other side. And then simplifying this, we have 4 times x minus 2 squared plus 9, and then we have y plus 1 squared. Yeah. And then equals 2, so 11 plus 16 plus 9. So we have 36, right? 36 here. And the goal here, sorry, this should not be r squared. No. I got this wrong. This should be 1, no? So we have no radius nga pala sa ellipse. My bad, no? So, sorry. I forgot about that. So the one here, the goal here is to make the things 1. So we have to divide this by 36. So the resulting equation, the right hand side will be 1. So we have here 4 over 36. No? So this will become what? So this will be 9. So we have x minus 2 squared and then over 9, right? Plus we have here y plus 1 squared and then over 4, right? So this will be 36, 1. So therefore, we can already see here that your h and k, okay, so the center here, h and k, that is equal to 2 and negative 1. Okay, which is your center. Now, to find the eccentricity, we have to first find the A, the B, and the C. So, actually, I can just substitute this directly so that I won't have to compute this. So, I can substitute this to this. So, we have E is equal to the square root of A squared minus B squared over A. Okay, so what is this? So, this is actually A squared and this is B squared. So, remember that in an ellipse, or the standard form of an ellipse, whichever denominator is the highest, that will be your semi-major axis squared. So therefore, we already have a value of a squared and b squared. But to find the a, no, so the a is equal to, or sorry, the a squared is equal to 9. Therefore, a is equal to, the square root of 9 is 3. So the eccentricity here will be the square root of, we have 9 minus 4 over 3. That will be equal to square root of 5 over 3. So that will be your answer. Okay, or I think I have a computation here. Or approximately, this is approximately 0.745. Okay, so that's it. All right, so we have an hyperbola here. I think this is the last one. So for the given equation of a hyperbola, find the center and the eccentricity. So now, what is the standard equation of a hyperbola? So the standard equation of a hyperbola, we have x minus h squared over a squared minus y minus k squared minus b squared is equal to 1. Okay? So, what is this? This is a horizontal hyperbola. Ano? So, how do we know that? Whichever is positive, no? So, if x is positive here, the x-axis is positive, then this is a horizontal parabola. And consecutively, remember that whichever is positive should be your A. No? And then for a vertical parabola, we have y minus k squared over a squared minus, we have x minus h squared over b squared is equal to 1. Okay? So this will be a vertical parabola. So based on this, we do not know yet no, if it is a vertical or a horizontal parabola. So we have to first do the completing the square. No? So grouping this again, we have x squared plus 4x. And then I could create a blank here already. And then we have negative 4y squared. So I can factor out the negative 4. So negative 4, factor out the negative 4. And then this is positive. So since this is positive, to make things positive, so this should be negative. So this will be divided by 4. So this will be negative 6y. Okay, and then plus blank. And then equals 2. So negative 28, this will become positive 28. Right? Okay, so simplifying this, what do we have here? Not simplifying, but completing the square. So we can add 4 here. So adding 4 here, so we do not have a coefficient here. So we can just add 4 here directly. And then for this one, so we have to add here 9, right? So 9 here, therefore we have to multiply this by negative 4. Therefore we have to subtract, no? Subtract 9 times 4, which is 36. Yes, 36. Simplifying this, we have x plus 2 squared, and then we have negative 4, and then y minus 3 squared is equal to, so what is this? We have 4, so 32. 32 minus 36, so negative 4. Okay? And then, the goal here is to make the right-hand side equal to 1. So, we have to divide this. We have to divide by negative 4. No? Okay? So, therefore, this will become negative. No? And this will become positive. So, I will just make this the first equation. So, we have y minus 3 squared. And then over 1. And then minus, we have x plus 2 squared over 4. And then equals to 1. So therefore, we can already see here that uh, h and k here is equal to 3 and negative 2. Sorry. No. This should be negative 2 and 3. Yeah. Okay. And then after that, what is this parabola? Sorry. What is this hyperbola? This is a vertical hyperbola. And this will be your a squared. This will be your b squared. Now, for finding the eccentricity, guys, is equal to what? No? So we have c over a. So c over a. So c over a here is, so we have already a given, but how about c? So the c here actually is different. No? So the c here, instead of a squared minus b squared, this is actually a squared plus b squared. No? So therefore, the eccentricity is equal to the square root of a squared plus b squared over a. So we know that a squared is equal to 1. So therefore, a is equal to 1. So the eccentricity here, so a squared is equal to 1, b squared is equal to 4, and then a is equal to 1 as well. So square root of 1 is 1. So the eccentricity therefore will be the square root of 5. So that's it. So this will be your eccentricity. Okay, so that's it for this lecture. I hope you learned something here. I still have my what do you call this? My review PDF, no, or handouts that are in PDF format. You can review some of the examples there to help you out in the exam this week. So that's it. Thank you guys, and good luck.